A consumer agency wanted to estimate the difference in the amount of caffeine in 2 brands of coffee. There's a sample of 15 1-pound jars from brand 1, giving a mean of 80 and a standard deviation of 5. Another random sample of 12 jars from brand 2 gave a mean of 77 and a standard deviation of 6. We want a 90% confidence interval for the difference in the population mean caffeine amounts, and we're asked what this interval tells us about the difference. Also, are there any conditions that must be satisfied for the interval to be valid? Let's talk about the conditions first. Notice that if we look at our sample sizes here, they're 15 and 12. Those are both small samples. So in order for everything to be valid here, we would need to know that we have caffeine amounts being normal for both brands, for both brand 1 and 2. So assuming normal caffeine amounts for both brand 1 and 2. Okay, so our summary statistics that we're given here for the first group is we have a mean of 80, a standard deviation of 5, and that was based off a sample of 15. So we have the 15 here, 80, and 5. Our second group had a mean of 77, a standard deviation of 6, and that was based off a sample of 12. So here's our 12 and our 6. And then when we're doing a 90% interval, what we do need to do is go to StatKey and look up our t-value. The degrees of freedom that we use for this is the smaller of n1 minus 1 and n2 minus 1. n1 minus 1 would be 14, n2 minus 1 would be 11, so the smaller one would be 11. So we need to go find our t critical value in StatKey using the t-distribution with degrees of freedom of 11. So t-distribution, degrees of freedom of 11, hit OK. And then when we're doing a confidence interval, we do two-tail, and we wanted a 90% interval, so we need to change the value in the middle to 0.9. So we can see we get a t of 1.796. So our interval will be sample mean 1, 80, minus sample mean 2 of 77. So centered at 3, plus or minus our t. And then we have here the square root of s squared, so 5 squared over its sample size of 15, plus 6 squared over its sample size of 12. So this will be 3 plus or minus 3.880, which gives us an interval from negative 0.88 to 6.88. So this is an interval for mu1 minus mu2. Notice that this interval has both positive and negative values. So it goes negative, positive. That also means that it contains the value of 0 in it. When we have this trend where the difference mu1 minus mu2 could be a negative number, or mu1 minus mu2 could be a positive number, or also that it could be 0, what we can say is that we cannot detect a difference between the two. We can't tell if the difference would be positive or negative. So we can't determine there's any difference in the population mean caffeine amounts for the 2 brands of coffee.